Today, I will explaining rectifiers presented by Dr. K. Srinivasulu from St. Peter's Engineering College. So here, what is the rectifier? So the main definition of the rectifier, the AC signal is converted into DC signal. The AC signal converted into DC, not a pure DC, pulsating DC. So whenever the input signal AC is converted into pulsating DC is called rectifier. So this process AC converted into pulsating DC process is called the rectification. Okay, so here rectifiers are two types, half wave rectifier and second one full wave rectifier. Sometimes full wave rectifier is also called bridge wave rectifier. Okay, so here main important how many types, what is the rectifier? Next one, how many types of rectifiers? Once again, I am explaining the definition of the rectifier. The input signal is AC. That AC signal is converted into pulsating DC is called the rectification. So types, how many types of rectifiers? The rectifiers are two types, half wave rectifier and second one full wave rectifier. So full wave rectifier is also sometimes called the bridge wave full wave rectifier. Okay, next, what is the half wave rectifier? So the process of removing one of the input signal establish a DC level is called a half wave rectification. Okay, so in this diagram, in the half wave rectifier, we are using only one diode. Only one diode. So that's what's called half wave rectifier. Okay, in half wave rectification, the rectifier conducts current during the positive half cycle of the input AC signal only. So here, so diagram, half wave rectifier diagram is there. Half wave rectifier circuit diagram consisting of transformer and one diode, one resistor. So that's transformer is belongs to the iron core transformer. Iron core transformer means audio frequency transformer. So this transformer is frequency very low. So that's why, so this type of transformers are used in half-wave rectifier. Okay, so a construction of the half-wave rectifier. So first one, transformer, a primary winding and secondary winding. So the diode is connected to the secondary winding of the transformer. So one more load resistor is also there, RL, load resistor. Okay, so here how to working the half-wave rectifier. So here AC signal means input signal. So here sinusoidal signal is applied to the input side of the half-wave rectifier. So whenever we are applied the sinusoidal signal to the half-wave rectifier, so here you will getting the only positive half cycle. During the positive half cycle, the diode is conducts only. Okay, during the positive half cycle, the diode conducts. Only positive half, remaining negative half cycles are stopped. That means in a negative half cycle, there is no current passing. Why? Because during the positive half cycle, the diode D is conducts. Okay, so next one. So how? So AC voltage across secondary terminals, AB changes polarity after each half cycle. So that means during the positive half cycle, the terminals are connected to positive to the diode, negative is ground. So during the negative half cycle, the polarities are will changes. So here during the negative half cycle, terminal A is negative. So diode is reverse biased and conduct no current. So that means during the negative half cycle, there is no current. So current flows through diode during the positive half cycle only. So here, during the negative half cycle, there is no current. So that's why the current is passing only positive half cycle only. In this way, current flows through load RL in one direction. Okay, so during the positive half cycle, the current is passing through the load resistor RL only. Next, disadvantage of the half-wave rectifier. Since the power is delivered only during one of the cycle of the input alternating voltage. Therefore, its power output and rectification frequency is low. Transformer utilization factor is also low. So the DC output power produced from the from the off-wave rectifier is not satisfactory to make a general power supply. So here the main disadvantage of the off-wave rectifier, where transformer utilization factor is very low. Okay, so here only one diodes are used. So that's why off-wave rectifiers are more drawbacks because of transformer utilization factor is very low, efficiency is also very low in off-wave rectifier. So why? Because of the we are using only one diode only. Okay. Next, output frequency of half-wave rectifier is equal to input frequency. So why? Because during the positive half cycle, so the input, for example, input is 2 volts. The same 2 volts will appear at output side also. Why? Because the diode is conducting. So how much voltage will apply at the input side, the same voltage will also appear at output side when it is during the positive half cycle. But during the negative half cycle, the diode is open. That means there is no current passing. So across the output, the voltage or current is zero. Why? Because of it is open circuit. That means there is no current passing. So that's why during the negative half cycle, there is no current. During the positive half cycle, the current will flow. So then only across the RL, some voltage will appear. Okay, so that's why, so our output frequency is called input frequency during the positive half cycle. Full wave rectifier. So in a full wave rectification, current flow through the load in a same direction of both half cycle of input AC. This can be achieved with two diodes working alternatively. So here in a full wave rectifier, we are using the two diodes. But in case of half-wave rectifier, we are using only one diode. Only one diode. So that's why the transformer utilization factor is also very low. The efficiency is also very low. Reflect factor is also very high. But in case of full wave rectifier, the efficiency is more comparing to the half-wave rectifier. The transformer utilization factor is also very high because of the we are using two diodes. One more important, in a full wave rectifier, we are using the center tap transformer. Center tap transformers are used in full wave rectifier only. So when we are using the center tap transformer, when you are using the two diodes, automatically the efficiency will increase. Yes, the transformer efficiency also increases. The ripple factor will reduce compared to the half-wave rectifier. So why? Because of we are using the two diodes only. Okay. So for one half cycle, one diode supplies current to load, and for next half cycle, another diode works. Okay. So here in this one full wave rectifier, here using the center tap transformer only. One more important, two diodes are used. So, but the transformer is iron core transformer. Iron core transformer means audio frequency transformer. Iron core transformer is only audio, low frequency. Iron core, audio, so low frequency. So this type of transformers are used in laboratory only. So in our laboratories, we are using only iron core transformers. we are using only audio frequency transformers. We are using only low frequency transformers. Why? Because in our laboratory, we are using the voltage very low, 230 volts only. So then only we are using the only iron core transformers. That is one of the very important point. So here output frequency of full wave rectifier, output frequency of full wave rectifier is equal double of the input frequency because of we are using two diodes only. We are using the two diodes. This means when input AC signal completes one cycle, rectified wave complete two cycles. So that's why frequency output is equal to 2Fin because of the we are using two diodes only. So then when you are using the two diodes, automatically the efficiency will increase. The transfer utility factor also will increase. The ripple factor will be reduced. But in case of a rectifier, the ripple factor is very more. So once ripple factor very more means the noise will be more. So our main objective of the rectifier to reduce the ripple factor. How to reduce the ripple factor? You will see the next classes. So in a half wave rectifier, the ripple factor is more. But in case of full wave rectifier, the ripple factor will be reduced because of we are using the two diodes. Even the output is also consists some AC component. So how to rectify that problem? How to reduce the ripple factor? That is the main task of the rectifiers. Okay, so how to rectify the ripple factor in rectifiers? So here center tap full wave rectifier. So that is the circuit diagram center tap full wave rectifier. So the center tap transformer is consisting of two diodes D1 and D2. A secondary winding A terminal and B terminal. R means load resistor. Circuit, that means center tap full wave rectifier circuit has two diodes D1 and D2 and a center tap transformer. Next, during the positive half cycle, diode D1 conducts, and during the negative half cycle, diode D2 conducts. So that means during the positive half cycle, only the diode 1 is conducts. At the same time, D2 is non-conducting. Okay. So whenever you do that during the positive half cycle, D1 is on. At the same time, D2 is off. When during the positive half cycle. So when during the negative half cycle, D1 is off, D2 is on. How can it is possible? We are the center tap transfer. Once we are the center tap transfer, automatically it will the process will be continued. It can be seen that the current through the load RL is in the same direction for both cycles. Fully wave bridge wave rectifier. Already I said fully wave rectifier, or sometimes it is also called the fully wave bridge rectifier. So in fully wave bridge wave rectifier is consisting of 4 diodes. Please to remember the bridge wave rectifier is consisting of 4 diodes. Once again I am give the points. In a half wave rectifier we use only 1 diode. In a full wave rectifier, we use 2 diodes. In a bridge wave rectifier, we use 4 diodes. In objective point of view, very, very important. How many diodes are used in a half wave rectifier? Only 1 diode. How many diodes are used in bridge wave rectifier? 4 diodes. How many diodes are used in a full wave rectifier? Only 2 diodes. Okay. So here, the bridge wave rectifier consisting of 4 diodes. Please to remember, but the transformer is the same, iron core transformer. Okay, RL, load resistor. So here the waveforms. So input signal during the positive half cycle, some output will get in. During the negative half cycle, during the another output waveforms. Okay, here during the first half cycle, D1 and D3 are conducting. Please all of see the diagram. So in the diagram, during the first half cycle, D1 and D3 are conducting. Why? D2 and D4 are in the off state. D2 and D4 are off state. So the diodes are off state. Okay, next. So during the negative second half cycle, D2 and D4 are conducting, while D1 and D3 are in the off state. Okay, so here, like that, how it is possible? We are using the center tap transformers. Okay, so full wave bridge rectifier advantage. Need for center tap transformer is eliminated. Output is twice than that of a center of circuit. So here, full wave bridge rectifier, you are not using the center tap transformer. Only the center tap transformers are used, only full wave rectifiers only. Next advantage, output is twice than that of center tap circuit. Disadvantage, the main disadvantage of bridge rectifier is it requires 4 diodes. Next disadvantage, internal resistance voltage drop is twice than that of center tap circuit. Okay, so finally, what I am saying about the rectifiers, what is the rectifier? How many types of rectifiers? So the rectifiers are 3 types: half wave rectifier, full wave rectifier, bridge wave rectifier. Sometimes only half wave rectifier and full wave rectifier. Full wave rectifier is also called the full wave bridge wave rectifier. That's what is called 2 types. But in case of half wave rectifier, you have only 1 diode. In case of full wave rectifier, using 2 diodes. In case of bridge wave rectifier, using 4 diodes. So that means whenever increasing the diodes, automatically the rectifier efficiency will also increase. Transfer utility also will increase. But ripple factor not reduced. Ripple factor is not reduced. How to rectify? How to reduce the ripple factor in a circuits? So whenever using the capacitor, automatically you will reduce the ripple factor. So whenever using the capacitor, automatically the rectifier ripple factor will be reduced. How to reduce the ripple factor using the capacitor? You will see the next class. Thank you for watching this video.